Assalamualaikum and a very good day. So today we are going into a new subtopic. In the previous video, I have explained about the conservation of linear momentum. This topic is the continuation of that topic, which is the conservation of linear momentum. And today we are going to talk about impact. Let's look at the outcomes of today's lesson. At the end of this lesson, you should be able to understand the definition of impact. What does it mean by impact in terms of engineering mechanics? And also, there are two types of impact, central impact and oblique impact. So you should be able to differentiate between these two types of impact. And then I'm going to share about the coefficient of restitution, or the symbol used for the coefficient of restitution is E. So what is the coefficient of restitution, how it is calculated, we are going to discuss in this lesson. And finally, we are going to solve a few problems related to impact. Let's look at the definition of impact. Impact occurs when two bodies collide with each other during a very short period of time. So therefore here the time is very short, the time of impact, and as I've mentioned in the previous video, due to the short period of time, then we can consider the external force as non-impulsive, and therefore this can be treated as one of the cases for the conservation of linear momentum. So due to this impact, relatively large impulsive force will be exerted between the bodies. Because these are internal forces, so it will be cancelled out because one force is acting on one direction, whereas the other force will be the same pair of force will be acting in the opposite direction, so they will cancel out. Okay, let's look at central impact. What is central impact is all about. So in this animation, you can see that particle A and particle B collide with each other. So VB1 is moving to the left and VA1 is moving to the right. So the contact point, if we draw a line, then this will be called the plane of impact. And if we draw a line passing through the center of gravity of both particles, then this is called the line of impact. So this is known as central impact, where two bodies collide with each other in this manner. Okay, so basically for central impact, after the collision, the body might be rebounding in the opposite direction as shown here. So this is again the central impact. The second type of impact is called the oblique impact, where the impact, the velocity is now coming from an angle. Okay, so the velocity VA1 is acting at an angle theta, whereas VB1 is at an angle phi, for example, in this illustration. And due to the impact, and this is called the oblique impact, and after the impact, the particles might be traveling in this direction. So we're going to have VA1 at an angle, VB1 at an angle, VA2 and VB2 is also having an angle. So this is different from central impact, where there is no angle involved for the velocity. So these two characteristics of impact differentiates what is the central impact and what is the oblique impact. Now let's look at the coefficient of restitution. So in a central impact, first these two particles is impacting or is moving at a velocity of VA1 and VB1, and after the impact they will rebound with a new velocity VA2 for particle A and VB2 for particle B. So how do we get the relationship between these four velocities? So the relationship between these four velocities is known as the coefficient of restitution, which is E is equal to VB2 minus VA2. This is the velocity of particles after the impact, divided by VA1 minus VB1. This is the velocity of the particle before the impact. Okay, so this is before impact, this is after impact, and if you can see the top of the fraction here starts with VB2 minus VA2, and the denominator is VA1 minus VB1. So there is an interchange here to calculate the coefficient of restitution. All right. Now let's look at more about coefficient of restitution. Let's say now the ball is dropped from a certain height and it will impact the ground. So after the impact, if the ball returns to its original height, this way it is known as elastic impact. In elastic impact, the value of coefficient of restitution E is equal to 1. This is the ideal case where there is no energy losses to surroundings, and in reality this can never be achieved, the elastic impact. Okay, because definitely when a ball is dropped on the ground, then it will not return to its original height because of the losses to surroundings in form of heat and so on. Another type of impact, the coefficient of restitution, is when you drop something on the ground and it does not rebound at all. This is an example of like you drop a clay, for example, or a Play-Doh, something like that, on the ground and there is no rebound. This is called plastic impact. Okay, this is called plastic impact, where in this case the coefficient of restitution E is equal to 0. Okay, E is equal to 0. So the range of the value the coefficient of restitution can have is between 0 to 1. So normally the coefficient of restitution may be equal to 0.8, for example 0.6. It totally depends on the type of material that is colliding with each other. All right, now let's look at the strategy of problem analysis for central impact. In the case when we have a central impact problem and we would like to solve the problem, the first thing to do is to apply the conservation of linear momentum equation. This is what we have learned in the previous lesson. So you have total mv1 is equal to total mv2. This is one equation that you have to apply as the first step to solve the problem related to central impact. The second is to use the coefficient of restitution. Why you have to use this? Because in the first equation here we're going to have two unknowns in one equation. So basically we cannot solve these two unknowns and we need an extra equation, and there is where the coefficient of restitution comes into play. So we have to use the coefficient of restitution equation here to get the second equation. And then finally, we're going to solve the simultaneous equations to get the value of velocity. That is for central impact. We'll look at how to solve this problem in the example later. In the case of oblique impact, so the first thing to do is to note that during an oblique impact, the y-axis needs to be established within the plane of contact. Okay, so the y-axis has to be defined as the plane of contact, and the line of impact, remember from my previous slide, is going to be the x-axis. So in this way, the impulsive force of deformation and restitution only acts in x direction. So then the second thing to do is to calculate the conservation of momentum in x-axis by using this equation. Sum of mvx1 equals to sum of mvx2. So remember, this is only in x-axis. So we're going to calculate the conservation of linear momentum in x-axis. Then number 3 is to apply the equation of coefficient of restitution in x-axis also. So you notice here, these are all in x-axis. vbx2 minus vax2 divided by vax1 minus vbx1. And this is to get vax2 and vbx2. And finally, we're going to need the value of velocity in y-axis. So the momentum is also conserved along y-axis, and therefore we're going to have mvay equals to mva2, or simply we can cancel out the mass, and we're going to have vay1 is equal to vay2, and so is for vby1 is equals to vby2. So this is how the problem is analyzed for oblique impact. Let's look at the example problem to understand better on how to solve the problem. So the 15 megagram tank car A and 25 megagram freight car B travel toward each other with the velocities shown. So they're going to collide. If the coefficient of restitution between the bumpers is 0.6, determine the velocity of each car just after the collision. So they are coming with 5 meters per second for car A, 7 meters per second for car B. After the collision, what would be their velocity? So this is what we want to find out. This is definitely a central impact problem because you see it is traveling in a straight line. There is no angle involved. So the first step to do is to do the conservation of linear momentum, which states that if we take positive to the right, then we have MAVA1 plus MBVB1 is equal to MAVA2 plus MBVB2. So we know all the masses, we know the velocity initially. So we have 15,000 kilograms. 15 megagrams is equal to 15 times 10 to the power of 3 kilograms. So 15,000 kilograms multiply with 5 plus 25,000 multiply with minus 7. Note that this is traveling in the opposite direction of the positive axis, so we're going to write it as negative. Is equal to 15,000 VA2 plus 25,000 VB2. So finally we can rearrange the equation, and this is what we have. So this is what I have mentioned earlier. We're going to have one equation with two unknowns. So this cannot be solved unless we have another equation. Now we apply the coefficient of restitution, which states that VB2 minus VA2 divided by VA1 minus VB1 is equal to E. Then E here is given as 0.6. So we have 0.6 equals VB2 minus VA2. These are unknowns. And below we have 5 minus minus 7. Remember, VB1 is traveling to the left, therefore it is going to be minus. So what we have here is, when we do some rearrangement, minus VA2 plus VB2 is equal to 7.2. So this is going to be our first equation. This is going to be our second equation. Then you're going to have to use your calculator to solve this simultaneous equation. Okay, we can solve simultaneous equation using your calculator, and when we solve this simultaneous equation, then we can get VA2 is equal to minus 7 meter per second, which means that after the impact, car A will travel backwards, will travel in the negative direction. Therefore, you have minus 7 meter per second. VB2 will continue moving forward, but with a slower velocity of 0.2 meter per second. Okay, that is example problem number 1. Let's look at example problem number 2. Okay. The ball strikes the smooth wall with a velocity of VB 20 meter per second. Now the velocity is coming at an angle. So definitely you know this is oblique impact. Although you can only see one particle here, this is also considered an impact because it is impacting another object. We can consider this wall, this non-movable wall, as another particle as well. If the coefficient of restitution between the ball and the wall is 0.75, determine the velocity of the ball just after impact. So we want to determine what is the velocity of the ball after the impact, which is this one, VB2. So first we're gonna have to determine our axis. So as I have mentioned earlier, let's look at our previous slide, the problem analysis for oblique impact. First, we need to establish y-axis in the plane of contact and x-axis along the line of impact. Now let's go back to this problem here. Where is our plane of contact here? This is the plane of contact. Okay, remember this is particle 1, the wall is particle 2. So this line here is going to be the plane of contact. Okay, let's write it here. This will be the plane of contact. And where is our line of impact? Is going to be along the center of gravity. So this will be the line of impact. So therefore, plane of contact will be y-axis and line of impact will be x-axis. So this will be our x-axis. Okay, so then we need to determine VB1 into x and y axis. So we have VBx is equal 20 cos 30 degrees, 17.32, and VBy is 20 sin 30, 10 meter per second, right? And we know that V wall is equal to 0 before and after impact, because the wall is never gonna move, so it is equal to 0. All right, so first let's straight away use the coefficient of restitution to get our first equation. So E is equal to V wall 2 minus VB2x. Remember, now when we have oblique impact problem and we have established the coordinate system like this, where the plane of contact is y-axis and the line of impact is x-axis, then we're gonna use the coefficient of restitution only for x-axis. So wall here it doesn't matter because it never moves. So V wall minus VB2x. Okay, remember we need to put this in x-axis, VB2x divided by VB1x minus V wall 1. Okay, so V wall is definitely 0, both of them. So what we have is 0.75 equals minus VB2x divided by 17.32. So we have then VB2x is minus 12.99 meter per second. This is going to be VB2 in x-axis. Remember, this is VB2. Okay, this is VB2, and the x-axis will be pointing this way, so therefore it is negative. So it clearly shows the negative signs in our answer here. Alright, so then we proceed with the conservation of momentum in y-axis, where we know that VB2y is equal to VB1y. This is why we need to define our coordinate system following the plane of contact and the line of impact, so that we can implement or we can apply all of these equations. So conservation of momentum in y-axis is equal to VB2y equals VB1y. So VB2y is also 10 meter per second. So finally, we can determine the magnitude of VB2 by squaring VB2x and VB2y and square root them back to get VB2 equals 16.39 meter per second. Okay. Let's look at one last example for the case of oblique impact. So again, this is moving in this direction. This is moving in this direction. There is an angle involved here. This is also an oblique impact problem. Okay. But the question is, how do we define the x and y axis? So remember from our previous analysis strategy that y-axis is established within the plane of contact and x-axis along the line of impact. So now we need to know where is the plane of contact and which line is the line of impact. Okay, so the plane of contact, sorry, the line of impact first is this one. This is the line of impact. So clearly this will be our x-axis, and this is the plane of contact. Okay, this is the contact point, so you're going to draw a line, and this is going to be the plane of contact. So x-axis will be along the line of impact, y-axis will be along the plane of contact. Remember, when you are dealing with oblique impact, always use this. This is the problem analysis strategy that you have to use so that you can be able to solve this problem. Now, we know VA is coming 15 meter per second in this direction, so we're going to have to resolve VA into x and y axis. So this is definitely negative x axis pointing this way and positive y axis pointing in that direction. So you're going to have VA 1x, use this small triangle given here, minus 15 y minus, because you know that the VAX will be in this direction, okay, and VAY will be in this direction. So it's a negative for VAX and positive for VAY. Okay, so therefore we have minus 15 times 3 over 5, it's minus 9 meter per second. VAY is then 15 times 4 over 5, you have 12 meter per second. We do the same for VB. So VB is acting in x-axis, along the x-axis, so we have VBX equals 8 meter per second, and therefore VBY equals to 0 because there is no velocity in y-axis for particle B. Okay. The first step is to do the conservation of momentum in x-axis. So we have MVx 1 equals to MVx2. So we have here two particles. So we're going to write MVA1x plus MBVB1x equals MAVA2x plus MBVB2x. We know all the masses MA and MB. We know VA1x and VB1x. So we substitute all the values. 4 times minus 9 for VA1x plus 2 2 kg for MB times 8 for VB1X equals 4 VA2X plus 2 VB2X. Then we're gonna have 4 VA2X plus 2 VB2X equals to minus 20. All right. We cannot solve the problem yet because we only have one equations, but we have two unknowns. So next we proceed with the coefficient of restitution, also in x-axis. So 0.8 is the value given, E equals 0.8 is equal to VB2x minus VA2x divided by VA1x, is this one, minus VB1x, which is 8. So we're gonna have minus VA2x plus VB2x equals minus 13.6. So this is going to be our second equation. So we have the first equation here, we have the second equation here. So next is to solve these two simultaneous equations, okay, using your calculator. And we're gonna have VA2x equals 1.2 meter per second, VB2x equals minus 12.4 meter per second. Okay, we haven't solved the problem yet because we want the magnitude. We want VA2 and VB2. This is only in x-axis. We need to determine what is VA2y and what is VB2y. Okay, the last step is to use the conservation of momentum in y-axis, and it states that VA2y equals VA1y. So it is in fact equals to 12 meter per second, the same value as VA1y. Same goes for VB2y, it is equal to VB1y, which is equal to 0. Now only you can calculate the magnitude of the velocities by using this. Okay, VA2x square plus VA2y square, square root, you're gonna get VA2 12.06 meter per second, and VB2 you do the same, you're gonna have 12.4 meter per second. Okay, so in summary, today we have learned about central and oblique impact. We have learned about the coefficient of restitution E, how to calculate it, what is the equation of the coefficient of restitution, and we have also learned about the pure elastic impact where E equals to 1, and also purely plastic impact where E equals to 0. And finally we have solved a few problems related to impact between two particles. Okay, so thank you for joining the class today, for watching this video. There is one more subtopic that I'm gonna share the video with you. So as for now, thank you, and I will see you in the next video. Thank you.